Welcome back to R for Economics. This time we'll be talking about VAR models, vector autoregression models. We need to install the package Vars. May take a minute. And then the library, and it'll go and grab all the other things that are needed. It has a data set called Canada, and Canada has in it the employment, productivity, real wage, and the unemployment rate. So if we want to run a reduced form VAR, so it's just a function of its lag, we can just run that using the var function, give it its data, and then where the data is already arranged in columns of each type. And then we can tell it what type, we can say none, and it will give us the coefficients going through. Now, if we want the summary of that, it will give us a summary, and it will go through and give us a summary of all the estimates, standard errors, t-values, p-values, and then also the variance covariance matrices. We can add a constant, we can add a trend, we can add both, and now we were able to see how the trend or a constant affects our VAR. So let's save one of these. We'll save the one with a constant, and we can plot it. We can see that we have a lot of output that we can look at. Here below we have the residuals, seems to do a pretty good job, the fit and the actual line, and then we have the PAF and ACF. So there seems to be some kind of relationship which might still be around. We can also generate the impulse response functions. And here we see an impulse on the employment. We can see that there's initially a positive shock in productivity, and then that diminishes over time. Likewise for real wage, but the opposite direction. And the unemployment rate drops and then increases, kind of expected. Now, if we want a structural VAR where the current time period could affect the current time period, or the current E could affect the current productivity. Here we have to construct an A matrix. So this is what's multiplied or factored out of all the models. So we're gonna first start with a diagonal, and it has to be NA on the diagonal. So anywhere where there's an NA, it'll try to estimate the values. Let's add a few more. So we're going to have 2, 1, 2, and 2, 1, and 4, 1 being changed. We can't have all of these because that will crash the model. It's over-identifying. So if we do a summary, we can see that our A matrix for our structural has the values on the diagonal, and then these two other points here and here. And we have the standard errors so that we can do statistical testing of these as well. We can also get the impulse response function for E. We can plot them. And then if we want just one of them, we can just say in the response, just do this one. And then we can see what the shock and how big the shock will be, and then the response over time. Okay, and we'll see you in the next video.